A huge thanks to Brian for sponsoring this video. Einen wunderschönen guten Morgen. This is where it's going to end. After 7-something years, this is my final mathematics video. And we are back at where we started, with an integral. And we are going to do it the way I like it the most here on this channel, in an improvised session. I'm fairly certain that I can figure this one out, where we have basically nested upper and lower bounds of this integral, and give it a shot for yourself, see if you can solve it and post your solution down there below. And I hope you are going to enjoy the video, which is gonna be sponsored by Brilliant once again. So keep watching up until the end of the video. On the one hand for the solution, on the other hand to hear me talk a bit about Brilliant, the most amazing sponsors one could possibly think of. So we are going to dive right in, and I hope you are going to enjoy this chill last video with your virtual daddy. Let us dive right in. So this right here is nested integral. There actually wasn't much space up here. This is why it's a bit cramped, but I think you get the gist of it. So we have in the lower bound down here of this integral right here, once again another integral, and they are all of the form x dx. On the one hand we have it in the 0 bound down here, and on the other hand we have it in the 1 bound up here. So the first thing we are going to do is we're going to start off with the outermost integrals, and then we are just going to push forward a tiny little bit. So that means we're gonna talk about this one at first, and after that we are going to talk about this one here, and then we are just going to work ourselves in a bit further. At least that's the plan. I think it's gonna work out. And the basics, what is the antiderivative of x? Well, we know that by now it's x squared over 2. So if you were to integrate from 0 to 1 x dx, it's gonna end us up with x squared over 2, and all of that from 0 to 1. Evaluating overall, 2 on the 0 bound is just gonna vanish, and on the 1 bound to 1/2. So overall, the first hurdle is already done. So this right here evaluates to 1/2, as well as this one right here. So we can try to take the next step, and I'm going to put it here because it's a bit of a clusterfuck, a bit of a mess. So we have this big outer integral, and all of that with another integra here and another one here. So this one goes up until 1, and then in the lower bound what we have is an integral from, now this one evaluated to 1/2, so it's going to be our lower bound of this integral right here, 1/2 to 1. So that's a bit of something new, at least it's from 0, not from 0 to 1, and all of that x dx, and still we have this one going on, x dx. And up here it goes from 0 to the other integral, which goes from, and now what are we going to have? This one evaluated to 1/2, so it's going to be the integral from 0 to 1/2 of x dx. X dx, and this big one x dx. At least this looks a tiny little bit better now when it comes to everything being written out. And now we can continue. Once again, our antiderivative is going to be x squared over 2. So let us handle this integral next, and this integral next. Okay, so if we evaluate it from 0 to 1/2, it's basically the same thing that we have up here, just to 1/2 instead of 1. On the 0 bound it's gonna vanish, and then we are going to have 1/2 squared over 2. 1/2 squared is 1/4 over 2 is 1/8. So the upper bound overall is gonna evaluate to 1/8. And what do we have right here? If it's from 1 to 1/2, then we are gonna end up with 1 squared over 2, because it's the upper bound here, and then minus, and we know what it's evaluating to at 1/2, exactly to 1/8. Meaning overall, this is 1/2 minus 1/8, so overall we can expand this to 4 over 8, so ending us up with 3 over 8 overall, which is not hard to do. So this one right here is 3 over 8, like this. And now we can write everything out in the next step. So this is gonna end us up with still a big ol' integral, but now with upper and lower bounds, which are pretty minimalistic at this point. Up here we have from 0 to 1/8, And down here we have from 3 over 8 to 1 x dx, x dx, and x dx. And we are almost done, guys. So guys, we did it. Kinda. We still have to evaluate a bunch of integrals. So now, at first, from 0 to 1/8. On the 0 bond, it's going to vanish as always. So this is going to end us up with 1/8 squared over 2. 1/8 squared is the same as 1 over 64. All of this time 2 is 1 over 128. Yeah. Okay. I think this should work out. Yeah. Okay. Perfect. And now on this lower bound that we have right here, this is going to evaluate us to 1/2. And then minus 3 over 8 squared over 2. Okay, so 3 over 8 squared is the same as 9 over 64, so 9 over 128. So 1/2 minus 9 over 128. This right here expanded by 64. We are going to end up with 64 minus 9 over 128, which is the same as 55 over 128. Okay, perfect. And now we are at the last iteration step, just a random, not a random, but a simple or polynomial integral of x dx, 55 over 128 to 1 over 128. Okay, and we know the procedure by now. This is going to end us up with 1 over 128 squared minus 55 over 128 squared, and all of this over 2. Now we can evaluate this. 1 over 128. 128 is 2 to the, let me see, it's 2 to the 6. No, 2 to the 7, right? 2 to the 7. So this right here is 1 over 2 to the 8. No, if we square this, so this is 14. 14, so 15. 1 over 2 to the 15 minus 55 squared over 2 to the 15, which is certainly something, I suppose. And I think this is the solution, and I hope I didn't mess anything up. You could probably still do some algebra here and figure all of this out, but this right here is totally a valid solution, I suppose. So yeah, go and figure it out for yourself. I ain't got time for that anymore because, as mentioned before, this right here was my last video, and I hope you did enjoy what you have seen today. And if you did so, then why not make sure to check out the contents of today's sponsor, Brilliant, to learn something new on a daily basis. Now, integrals are, in my opinion, one of the pinnacles of mathematics, and I certainly love to solve integrals, always ahead. Since I started with university, it's just a whole magic world, and the graphical interpretation behind integrals, it's even more magical than just plain or calculations. And there are so many interpretations of Riemann sums and trapezoidal rules and other stuff that you can do with integrals. There are endless possibilities to interpret something like this. And Brilliant is one of the main tools that I use to help my students learn about those very interpretations right there in my classroom. And this is what I appreciate most about Brilliant. It doesn't matter where you are. On the go, use the app. At home or in the classroom, use it on your computer. Brilliant is there for you to provide you with some of the most high quality and insanely useful STEM content out there on the internet. And it really doesn't matter what you want to learn. It's the mathematics that we did today, or maybe physics, computer sciences. They got everything that you can quite possibly think of in the entire STEM field. They provide you with everything. And the best thing is, if you are at university, for example, you tell Brilliant that you are a bachelor's, for example, right now. So they provide you with the exact courses that you need for your current level of education. You are at high school, well, then this simple proof about triangles is gonna suffice. Brian is just absolutely amazing at what they do, and they are so personal with you. I just really enjoy it. It's like a big family over there on Brian, and you should become part of the family by using my linky down there at the top of the description, brian.org/flammy. With it, you are going to get a 30-day free trial of amazing awesomeness. Try out the whole landscape of Brian for completely free. See if it's something for you. And if it is, if you feel like this could turn into a long-term relationship between you and the services, then why not make sure to use the link key in its entirety or my QR code somewhere up here in the corner to get 20% off an annual premium subscription, which is an amazing deal. They have so much content over there on the website, and it doesn't matter where you are in your studies, they provide you with something that is of value to you. Trust me, they do. It's just absolutely fantastic what they provide over there, and just check it out. It really doesn't hurt. Use the link and support the channel this way for one last time. And also Brian, which I want to thank so much for sponsoring and supporting this channel over the years. And you thought I was done, huh? No, I was not, because the problem is not done. This right here is for the people who watch till the very end, up until the end of the sponsored messages. One last bit of algebra for you. I just want to see what this evaluates to. I'm not a fan of just leaving something like this how it is. You know me, I love to approximate and shit. So let's go ahead and get started. It's outtake bonus time. One last time. Yeah, okay. So let's start off with 55 squared. So this is 50 times 50. At least I heard that it is what it is. So this right here is 2,500. And also it's, yeah, that was a bit stupid, right? So let's do 50 times 5. And that's 250. I'm being a goofball right here, right now, huh? Let's spend some more time together. Let's just goof around the time a little bit. So 55 squared. I'm being stupid right now. I forgot a factor. I'm getting a bit confused because of the 2 5s here. So this is 50 plus 5, but squared. This is the same as, yeah, this is the same as 50 squared. And this is what we did right here. Plus 2 times 5 times 15. Okay, cool. Yeah, this is the one that I forgot. 5 squared here, plus 25. So we got this factor of 250 2 times overall. So this evaluates to 3,025. Okay, good. So we got 1 minus 3,025. Divided by, okay, 2 to the 15. So what do we got? We got 2 to the 10th power. This is 1,024. 2,048. And then we have 4,096. And after that, what do we have? This is 2 to the 12th. Then to the 13, we got 9,192. Okay, and to the 14. Okay, it's getting a tiny little bit more spicy now. What do we have right now? So we have 18,384. And to the 15th power, this is where it gets exciting. We have 63,768, I suppose. I hope I didn't goof up. So this right here is 1 minus 3,025 divided by 36,768. Okay, 1 minus 3,025 is the same as a negative 3,024 divided by 36768. Okay, yeah, and this is totally a value, I suppose. But we are not done yet. Let's spend some more time together. We still have a bunch of minutes to go, I suppose. So we have a common factor of 2. Do we have a common factor of 4? We even have a common factor of 4 because 24 is divisible by 4 and 68 too. So yeah, that's a nice trick to know. Let's just start off with 2, I suppose. So this is negative 1,512. And this divided by 2 is obviously the same as 18,384. Yeah, divided by 2. This is negative 756 divided by, and by 2 once again, divided by 9,192. Oh yeah, it's even divisible by 8. Oh, this is nice because 24 is divisible by 8. So let's divide it by 2 even further. So this right here is 378. Minus 378 divided by the next iteration, 4,096. I should have computed the first one at first, and then everything should have been easier. And it seems to be a number divisible by 16. 3,024, I didn't know that, divisible by 16. So another 2. So this right here is 180, 185, 189, negative 189. Okay, this is where we reach a limit, I suppose, divided by 2,000, yeah, 2,048. And this is where we actually reach a limit of this computation, because obviously this is just a multiple of 2, no other numbers, and 189 is a number. Maybe it's a prime number, I don't know. Maybe you can find out. Hope you did enjoy what you've seen today. Thank you very much for everything you have done over the years for my channel, even if it's just watching the video or even hate watching the video and leaving some mean comments down there below. I couldn't give less of a fuck if you insult me, and thank you for watching. I'm gonna see you sometime soon, I suppose. Have a fabulous day. See ya.